Today I am going to start exercise 2.4 of class 9 polynomials chapter. Along with this, the practice exercise for 2.33 is also solved. So let's begin. First question, determine which of the following polynomials has x plus 1 as a factor. 4 polynomials again. Now here, factor theorem, what it is, when do we say a thing is a factor? If p of x is a polynomial of degree n greater than or equal to 1, and a is any real number, then x minus a is a factor of p of x if p of a is 0, and p of a is 0 if x minus a is a factor of p of x. And say the other way also. Okay, that means if you put a value of a in place of x and you get it is 0, then we say that x minus a is a factor. Now let us start with the first question. X square plus x raised to 3 plus x square plus x plus 1. Now x plus 1 is a factor, you say. So if x plus 1 is a factor, then x plus 1 must be equal to 0, and the 0 of this factor is x is equal to minus 1. This means p of minus 1 must be 0 for x plus 1 to be a factor. Okay, so let's put x is equal to minus 1 in this polynomial. P of minus 1 is equal to minus 1 raised to 3 plus minus 1 raised to 2 plus minus 1 plus 1. Minus 1 raised to 3 is minus 1 into minus 1 into minus 1. It is minus 1. Minus 1 into minus 1 is plus 1. And this plus minus will be minus. So it will be minus 1 plus 1 minus 1 plus 1. So plus minus cancels, plus minus cancels. So you are getting p of 1 minus 1 is 0. Since you are getting p of minus 1 is 0, we can say x plus 1 is a factor of the given polynomial x raised to 3 plus x square plus x plus 1. Therefore, p of minus 1 is a factor. Okay, let's take the second one. X raised to 4 plus x raised to 3 plus x square plus x plus 1. Now let's again put x is equal to minus 1. Minus 1 raised to 4 plus minus 1 raised to 3 plus minus 1 raised to 2 plus minus 1 plus 1. Minus 1 multiplied 4 times will be plus 1. Minus 1 multiplied 3 times will be minus 1. Minus 1 multiplied 2 times is plus 1. So your answer things will be plus 1, minus 1, plus 1, minus 1, and plus 1. This last number plus 1. So these two cancels, So you are left with only with 1. So my p of minus 1 is plus 1. Since p of minus 1 is plus 1, it is not equal to 0. So p of minus 1 is not equal to 0. Therefore, x plus 1 is not a factor of the polynomial. Third bit. This one. Again, let's calculate p of minus 1. Minus 1 raised to 4 plus 3 into minus 1 raised to 3 plus 3 into minus 1 square plus minus 1 plus 1. It will be 1 minus 3 plus 3 minus 1 plus 1. Minus 1 plus 1 cancels. 3 minus 3 also cancels. Only plus 1. So it is p of minus 1 is plus 1. Again, p of minus 1 is not 0. Therefore, x plus 1 is not a factor of the polynomial. Let's take the next. Fourth. Again, you put x is equal to minus 1. Minus 1 raised to 3 minus minus 1 raised to 2 plus minus 2 plus root 3 minus 1 plus root. So this minus and this minus will become plus. So this will be plus. So it will be p of minus 1 minus 1. Now this is going to be plus. So it will be plus 2 plus root 2 plus root 2. Okay. So this will be minus 2 plus 2 plus root 2 plus root 2. Root 2 plus root 2 is 2 root 2. Clear? Next. Therefore, x is equal to minus 1 is not a factor. Use factor theorem. Question number 2. Use factor theorem to determine whether g of x is a factor of p of x in each of the following cases. g of x. So this is g of x. If this has to be factored, then I'll have to write this is equal to 0 and calculate the value of x. And that value I have to substitute here and see if I'm going to get 0. So let's start with the first one. So first one, p of x is 2x squared. So 2x raised to 3 plus x squared minus 2x minus 1. And g of x is x plus 1. So let's put g of x is x plus 1 to be a factor. We have to x is equal to 1. So 0 of this will be minus 1. So p of minus 1 must be 0. So let's calculate p of minus 1. P of minus 1 is 2 minus 1 raised to 3 plus minus 1 raised to 2 minus 2 into minus 1 and minus 1. This will be minus 2 into minus 1. This will become plus 1. This is minus 1. It will be minus 2 plus 1 plus 2 minus 1. Plus 1 minus 1 cancels. Plus 2 minus 2 cancels. It is 0. P of minus 1 is 0. Therefore, P of x plus 1 is a factor of the polynomial. Next, x is a polynomial. So here x plus 2 is 0 means x should be equal to minus 2. So here p of minus 2 must be 0 for the factor. So let's calculate now p of minus 2. P of minus 2 is minus 2 raised to 3 plus 3 into minus 2 raised to 2 plus 3 minus 2 plus minus 2 into minus 2 into minus 2, 2 to the 4, 4 to the 8. And 3 minuses, so it becomes minus 8. And this one is minus 2 into minus 2 is plus 4. 4 3 is a 12, it is a positive. Plus minus will be minus 6. It will be minus 8, 3 into 4 plus 3 into minus 2. It will be minus 8 plus 12 minus 6 plus 1. Okay. So 8 plus 6 is minus 14. So 12 plus 1 is 3. And 8 plus 6 is minus 14. It is minus 1 is the answer. So p of minus 2 is not equal to 0. Therefore, x plus 2 is not a factor. Next. Okay. Now let's see the third one. X minus 3. That means x should be equal to 3. So you'll have to calculate p of 3. So p of 3 must be 0. So let's calculate p of 3. 3 raised to 3 minus 4 into 3 raised square plus 3 plus 6. So 3 cube is 27 minus 3 square is 9 and 3 plus 3. So is 27, 4 9s are 26 plus 3 is, that is 36. 27 plus 3, 30, 30 plus 6, 36. 36 minus 36, 0. Therefore, p of 3 is 0. Therefore, x minus 3 is a factor of the polynomial. Find the value of k if x minus 1 is a factor of p of x in each of the following cases. So p of x is equal to x squared plus x plus k. So here we have to find x minus 1 is a factor. So if x minus 1 is a factor, then if you put x is equal to 1, then it's p x minus 1 is 0 and x is equal to 1. So if you put x is equal to 1 in the polynomial, it should be equal to 0. That means p of 1 should be 0. Let us say p of x is this. So let us x has x minus 1 to be a factor. P of 1 must be 0. So p of 1 will be 1 square plus 1 plus k must be equal to 0. 1 square is 1 plus 1. 1 plus 1 plus k. 2 plus k is 0. 2 k is equal to minus 2. Next. Second one. Again here again same factor. So let's calculate p of minus 1. Sorry, p of 1. So p of 1 is equal to 2 into 1 raised to 2 plus k into 1 plus 2 equal to 0. So this is 2 plus k plus root. K is equal to, take 2 this side, minus 2, take root 2 this side, minus 2 root 2. K value is minus 2 minus root 2. Third one, again put K is equal to 1. K 1 square minus root 2 into 1 plus 1. 1 square is 1 only, so this is K, this is root 2 plus 1. K minus root 2 plus 1. So K will be equal to minus root 2 will become plus root 2 and plus 1 will become minus 1. This is the value of K. Next, put again K is equal to 1. So K 1 square minus 3 into 1 plus K is equal to 0. That is K minus 3 plus K is equal to 0. K plus K is 2K. 2K minus 3 is equal to 0. Take 3 this side, it becomes 3 upon 2. K will be 3 by 2. Yeah. Factorize. Factorize x. 12x square minus 7x plus 1. This is the first one. Now, to factorize, we have to follow the splitting the middle term method. Because 12 is not a perfect square, 1 is also not a perfect square. So, that follows the splitting the middle term method. In the above expression, the coefficient of x square is 12 and the constant term is 1. So 12 and 1 must be multiplied and we get 12. 12 ones are 12 letters. So we now find the factors of 12 such that if you multiply, we should get 12, and if you add the factor, we should get the middle term minus 7. This, I have said here, add. This sign in front of the constant term will decide whether you have to add or subtract. Here it is plus, that's why I said it is to be added. Yeah? So this will decide what to do. That's why, because there's plus sign, so we should add it. The sign before the constant term will decide if we have to add or subtract to get the middle term. Our sum is 12x square minus 7x plus 1. Now 12 into 1 is 12. So let's find all the factors of 12. Factors of 12 is here. 1 into 12 is 12. 1 plus 12 is 20. 2 6 are 12. 2 plus 6 is 8. 3 4s are 12. 3 plus 4 is 7. So I want the middle term is 7. And here I am getting 13. So this is rolled out. Here I am getting 8. Is also rolled out. So this is the one I said. My factors should be 3 and 4. So I write it. 12x square minus 3x minus 4x plus 1. Thus splitting the middle term. 7 has been written as minus 3 and minus 4. Now let us take common from these first two terms, common from the next two terms. Take common, which is 3x is common. Because 3 4s are 12, 1x outside, 1x inside. So 12x square minus 3x. Here nothing is common, so take 1 minus 1, 4x minus 1. So now if you take this 4x minus 1 in the first bracket and other bracket will have 3x minus 1. This is the factors of this polynomial. Next. Let's see the second. Now here 3 and 2 are the numbers. So 2 into 3 is 6. So we find factors of 6. We add, you should get 7. This is plus sign, so you should add to get 7. So 1 into 6 is 6 and 1 plus 6 is 7. So you can write this as 1x plus 6x plus 3. Now I take common from the first two terms. X, 2x plus 1, 3 common, 2x plus 1. We got 2x plus 1 common again. In the second bracket, x plus 3. This is your factors. Third one, 6x square plus 5x minus 6. So 6 into 6 is 36. Factors of 36, if you subtract, you should get 5. Okay, so it is 4 9s are 26. 9 minus 4 is 5. So you break the middle term as 9 plus 9 minus 4 and write the first and last term as it is. And take common from the first two terms, common from the last two terms. 3x 2x plus 3, 2, 2x plus 3. Take out 2x plus 3 common again, will be left with 3x minus 2 in the second. Next. Here, 3 into 4 is 12. Factors of 12, if you subtract, you should get 1. How is it? 4 and 3 is itself is a factor. 3 into 4 is 12 and 4 minus 3 is 1. So this should be your factors which we need to break. But I want minus 4. So I write minus 4 plus 3. It will be minus 4x plus 3x minus 4. Common, only x is common. 3x minus 4, nothing is common, 1. So your answer will be 3x minus 4 and x plus 1. Clear? Now again, factors. X raised to 3 minus 2x square minus x plus 2. So this is a cubic polynomial, that is, it's a degree 3. So since it's a degree 3, we have to first find one of the factors by using our factors there. Now, let us see how this. This is a polynomial of degree 3. We have to find one factor using factor theorem. So let us find one factor by putting x is equal to 1. That is, we will find x of, that we will find p of 1. So let's put p of 1. 1 raised to 3 minus 2 into 1 raised to 3 minus 1. This is 1 minus 2 minus 1 plus 2. So minus 1 minus 2 is minus 3. 2 plus 1 is 3. So 3 minus 3 is 0. So since you are getting 0, that means we can say that since p of 1 is 0, we by putting x equal to 1, thus we can say that x minus 1 is a factor of the polynomial p of x. X minus 1 is a factor of this polynomial. Once you have found one factor, now you divide this polynomial by x minus 1. Let's do the division. So now we have to divide px by x minus 1. Let's here the first term is x raised to 3. And here the first term is only x. To make x into x raised to 3, I need to multiply with x square. So x square into x will be x raised to 3. So you have to choose this term in such a way that you get this term exactly the same term. Then x square into minus 1 is minus x. So it will be x raised to 3 minus x square. Now you have to subtract it, so you have to change the signs. This will become minus and this will become plus. Once you plus and minus, this plus minus will cancel. So minus 2x square plus 1x square is minus 1x. Bring the next term down. Minus x plus 2. Now I want a minus sign. I should take minus sign here. I want x square, have 1x, take 1x. It will be minus x. Minus x into x is minus x square. And plus minus minus is plus x into 1 is x. So it will be minus x square plus x. Change the sign here. It will be plus. This will become minus. So now this plus minus will cancel. Here minus x is minus 2x. And this 2 bring it down. I want minus here, so I should take minus here. 2x I want. X is here, so I need only to take 2. So minus 2 I should take. Minus 2. Minus 2 into x is minus 2x. Minus minus 2 is plus 2. So if you see here, in the sign here, that's minus. Minus plus cancels. Plus minus cancels. Your remainder is 2. That means this and this together are the factors of this. That means this can be written as x minus 1 into x square minus x. Now you have to factorize this by splitting the middle. So x square minus 2x plus x minus. Again common x minus 2 plus 1 x minus 2 x minus 1 x minus 2 x plus 1. Okay. This is the factors of this polynomial, cubic polynomial. I am clear. Now let's try the second one. This is the second one. X raised to 3 minus 3x square minus 9x minus 5. Now put x is equal to minus 1. Because you see you are having all signs negative. To take a negative sign, then this will become positive, this will be negative positive. So that could be here. So that's why you will have to decide whether to take plus 1 or minus. The previous sum, all the signs were positive. So I took 1, and here all signs are negative. I have taken minus 1. Now see here. Minus 1 I take, minus 1 raised to 3, minus 3 into minus 1 square. So this will be minus 1 minus 3 plus 9 plus minus 5. Okay, 5, 3, 8. 8 minus 1, 9. 9 minus 9 is 0. I'm getting 9 is P of minus 1 is 0. That means P of is equal to x is equal to minus 1 I put. So it will be x plus 1 will be a factor. So x is equal, so the x plus 1 will be a factor of this. So now we have to divide the polynomial P of x by x plus 1. Here again x cube I need. I have 1x, take x square into x and x square into 1 will be x is to 3 plus x square. Change the sign. Both are negative. So this is plus, this is minus, this will cancel. And this will become minus 4x, minus 9x. Take minus 4x, will become minus 4x square minus 4x. Change the sign. So this will cancel. Minus 9 plus 4 is minus 5. Bring this down, minus 5. I want a minus sign here, take a minus. 5x you require, x is here, take only 5. So minus 5. Minus 5 into x is minus 5x. Change the sign. Subtract it. This cancels. This also cancels. 0. So that means this polynomial is equal to this into this. You see here x plus 1, x square minus 4x minus 5. Splitting the middle term, x square minus 5x plus 1 minus 5. Common x plus 5 in x plus 1, x plus 1, x minus 5. This bracket is 2 times. You can also write it as x plus 1 whole square into x minus 5. Now, I think that's there. Now, the next question is the next polynomial, that is so find factors, put x is equal to minus 1. So that means you have to calculate P of minus 1. P of minus 1 is minus 1 raised to 3 plus 13 minus 1 square plus 32 into minus 1 plus 20. That is minus 1 plus 13 minus 32 plus 20. 20 plus 13 is 33. 32 minus 1 is minus 33. So 33 minus 33 is 1. Okay. So that is P of minus 1 is 0. That means x plus 1 is a factor. So we have to divide this polynomial by x plus 1. Now divide by x plus 1. x3, so take x square, will become x square plus x raised to 3 plus x square. Change the sign. This cancels. Plus 13 minus 1 is plus 12x square. Bring the next term. You want a plus sign here. So take plus sign. 12 you require, there is no number, take 12. 1x square you require, 1x is here, take 1 more x. You will have to take 12x. So this will become plus 12x square plus 12x. Change the signs. This will be plus 12x square minus 12x square will cancel. 32x minus 12 is 20x. Plus this number is greater, it's having a plus sign plus. bring that number down, plus 2. Now I want a plus sign, take plus 20 and x is here already, so just take 20. So it is plus 20x plus 20. Subtract it, 0. So factors of this will be these two. So splitting the middle term again, okay, 10 2s are 20. 10 plus 2 is 12. So you will have to break this as 10 plus 2. 10x plus 2x. Common x plus 10 plus 2 into x plus 10. So x plus 1, x plus 2, x plus 10. Fourth one. Here 2 are negative, 2 are positive. So take positive. Take 1. Put value of 1. 2 raised to 1. This 2 plus 1 minus 2 plus 1. 3 minus 3 is 0. So P of 1 is 0. So y is equal to 1. Thus we can say y minus 1 is a factor. Y minus 1 is a factor. Now let's divide P of y by y minus 1. 2y raised to 3 you require. So 2 you require. So I take 1y is there, take 2 more y's. So 2y square into y will be 2y raised to 3. And minus 1 into 2y square is minus 2y raised to 2. Now change it. Plus and minus will cancel. Plus y square plus 2y square will be plus 3y square. In the next term, 1 plus 3y square. So you have 1y, you take 1, so plus 3y. So this will be plus 3y square minus 3y. In sign, plus minus should cancel. Minus 2 plus 3 is minus 1. Plus 1. Bring the next one. So it is plus y is there. So just take plus 1. 1 into y is y. 1 into minus 1 is minus 1. Change it. Well, cancels. This cancels. And this is 0. So your factors will be this. Now, splitting the manner 3, you are going to add the factors. So 3, 2 ones are 2. So 2 plus 1 is 3. Take common 2y, y plus 1, plus 1, y plus 1, y minus 1, y plus 1, and 2y plus 1. Now we start with the practice exercise 2.33. So where the questions given. Let's start them. Okay. So I am solving it. Let's see the first question. First question. Using remainder theorem, find the remainder when p of x is divided by g of x. So the first one. Here this is a polynomial. And the 0 of g of x, that is x minus 1 is 0, x is equal to plus 1. This will be the value of the 0 of this polynomial x minus 1. So you will have to put x is equal to plus 1 in this polynomial. Because it is said that this is dividing this. So here f of minus 1 plus 1 is equal to 4 plus 1 raised to 4 plus minus 3 into plus 1 raised to 3 minus 2 plus 1 square plus 1 minus 7. Okay. This will be only 1. This will be 1. This will be 1. This is 1. So it will be 4 minus 3 minus 2 plus 1 minus 7. 4 plus 1, 5. Okay. And minus 3, 2 minus 3 is 5. So 5 minus 5 minus 7. So 5 minus 5 minus 7. F of plus 1 is minus 7. The remainder is minus 7 when f of x is divided by x minus 1. So this and this cancels. So this is now What is this? G of x is x minus 2 upon 3. That means if you take this minus 2 down this side, it will become x is equal to plus 2 by 3. So you will have to find f of 2 by 3. F of 2 by 3 is 9. Put the values 2 upon 3 raised to 3 minus 3 into 2 upon 3 raised to 2 plus 2 upon 3 minus 5. Now 2 raised to 3, 2 into 2 into 2 is 8. 3 3s are 9, 9 3s are 27. 2 square is 4, 3 square is 9. 9 into 8 upon 27 minus 4 upon 9 plus 2 upon 3 minus 5. Now you see 9 can cancel this. How many times? 3 times. Here also 3 can cancel this. 3 can cancel 9. 3 3s are 9. Okay. So what are you left with? See how it is? 8 upon 3 minus 4 upon 3 plus 2 upon 3 minus 5 upon 1. LCM is 3. Clearly you are seeing. So this 8 minus 4 plus 2. And this should be multiplied with 3. 3 by the 15. So 8 minus 4 plus 2 minus 15. 8 plus 2 is 10. Minus 4 minus 15 is minus 9. Minus 9 by 3. Minus 9 by 3 is the remainder. That means we can write it is minus 3. 2 is the remainder. If the polynomial this and this leaves the same remainder when divided by this, find the value of it. That means when you are dividing this polynomial by x minus 2, you will get a remainder. And if you divide the second polynomial by x minus 2, you will get another remainder. These two remainders are equal, it says. Let us see how it is. P of x, P1x is equal to this is divided by x minus 2. Then 0 of x minus 2 is 0 is x equal to plus 2. Therefore, P1 of 2 is the remainder. So let's put P1 2. P1 2 equal to 2 raised to 3 plus a into 2 raised to 2 plus 3 into 2 minus 5. It will be 2 raised to 3 is 8 plus 4 into 2 square is 4. 3 into 2 minus 5. That is 8 to the 16, 4a plus 6 minus 5. So this is 6 minus 5 is 1. 1 plus 16 is 17. 17 plus 4a. So this is the remainder when x minus 2 divides the first polynomial. Okay. Now let us take the second polynomial and you're going to divide it by again x plus x minus 2. So you calculate p of 2, which is p2 of 2. Now let us see. Here 2 raised to 3 plus 2 raised to 2 minus 4 into 2 plus 8. So 2 raised to 3 is 8. This is 4. 8 plus 4 minus 8 plus 8. Minus 8 and plus 8 cancels. So 4 plus 8. This is the second remainder. But what it is given, the two remainders are same. Let's equate P1 and P2. I'm going to equate P1 and P2. Because P1 is equal to P1, 2 and P2, 2 both are equal. So let's put the values. 17 plus 4a is the first answer and 4 plus a is the second answer. Are equal. Let's take a this side and 17 this side. 4a minus a is equal to 4 minus 17. 3a is equal to minus 13. A is equal to minus 13 upon 3. Yeah. Next. This is a polynomial and this is the second polynomial. Are divided by x minus 4 leaves the remainder r1 and r2. When you divide this by x minus 4, you get remainder r1. When you divide the second polynomial by x minus 1, you get the second remainder r2. Okay. The same way as we have done previously, this also is just slightly different. So x minus 4 is the factor, the dividing factor. That means x is equal to plus 4. Therefore, R1 of 4 is the remainder. So let's calculate R1 4. So A 4 raised to 3 plus 3 4 square minus 3. So this is 4 cube is 64. 4 square 16 minus 3. It is 64a plus 48 minus 3. So this is 48 minus 3 is 45. 64a plus 45 is the first remainder. Now let's calculate the remainder for the second polynomial, that is R2. R2 4. R2 4 is 2, 4 raised to 3 minus 4 into 5 into 4 plus 8. This is 2 into 64 minus 5 into 4 plus 8. This is 128 minus 20 plus 8. This is 108 plus 8. This is your second remainder, R1, and this is the R1, this is R2. Now you say that our first case you take R1 is equal to R2. When you take the first case, R1, what is R1? 64a plus 45. R2 is 108 plus 8. So let us take a is on one side and the numbers on the other side. It will become 64a minus a, 108 minus 45 is 63a is equal to 63. A is equal to 63 upon 63 is 1. Value of a is 1 if R1 and R2 are equal. Second case, R1 plus R2 is 0. R1 and this is R2. Total should be 0. So 64 plus a is 65a. 65a and 45 plus 108 is 153. Take 153 this side minus 153 upon 60. This is the value of a if R1 plus R2 is 0. Third case, 2R1 minus R2. That is 2. The 64a plus 45 minus 108 plus 8. Open the bracket. 2 into 64 is 128 plus 45 into 2 is 90 minus 108 minus plus minus a is equal to this. So here 128a minus a is 127a. 127a. 108 minus 90 is minus 18. You get this right? So 18 upon 127 is the value of a when 2R1 minus R2 is 0. Next. This is a practice exercise given for this based on exercise 2.4. Try this out and watch my next video on exercise 2.5. I've solved this. I've solved it separately in a different exercise. So just watch this so that you will be able to get the like it. Okay, all right.